Hey guys, welcome back to the 2017 BMAT Section 2 walkthrough by me. My name is Faraz, I'm a Cambridge University medical student. In this video I'm going to tell you guys all about my solutions to this paper, which in my opinion isn't that easy a paper, it's quite a difficult one, and I'm going to show you guys how to tackle it. One other thing is, if you guys want to get better at tackling hard BMAT questions and just learn how to do the BMAT in general, check out sigmamed.co.uk. Me and Hamza, one of my Cambridge friends, have created a BMAT course that teaches you guys all you need to know about doing well. It costs less than the price of a single hours of tutoring and contains around 4 hours of content of 2 Cambridge medical students teaching you guys exactly what you need to know. For just £30, this course is reasonable, up to date, and can make a huge difference to streamlining your BMAT preparation and helping to boost your score. If you guys are sitting the BMAT this year, check out sigmamed.co.uk right now. But without further ado, here's part 3 of the BMAT 2017 walkthrough. Okay, so welcome to part 3 of this BMAT 2017 section 2 full walkthrough. So 19. A swimming pool is 10 meters wide, a loud sound is made in the water 2 meters from one wall, and the reflected sounds are detected with a microphone placed next to the sound source. The reflection from the wall 8 meters away arrives 0.01 seconds after the reflection from the wall 2 meters away. Let's draw this out. Let's say those are the walls. Let's say this is the sound source and receiver. So this gap is 2 meters. This gap is 8 meters. So overall, when the sound reflects, it's traveling 4 meters. And the sound reflects, it's traveling 16 meters. And the time delay is 0.01 seconds. So the difference in distance is 12 meters. So therefore, to travel that additional 12 meters, it's taking 0.01 seconds. So now we use our standard equation. Speed is equal to distance over time, which is equal to 12 over 0.01. We don't need to do the calculation because we can clearly see that none of these answer options begin with 1, 2. Therefore, the correct answer option is E. As I always say, skip unnecessary calculations. You don't need to do them. We can see that 0.001 isn't going to change the first 2 digits of the number in terms of that you have 12 and then something else. So therefore we can disregard the first 4 answer options and we instantly know the answer option is E, 1200 meters per second. Okay. Question number 20 then. Express this series of terms as a single algebraic fraction. So I'll show you how to go about doing this. So if you want to add or subtract things when they're algebraic fractions, you need them over a common denominator. So we need to cross multiply each fraction by whatever it's missing on the bottom. So the first fraction will become 1, x minus 1, x over 2x, x minus 1, x. To that we're going to add 1, 2x, x with the same denominator, which I'll skip writing. And from this, we're going to subtract 1, 2x, x minus 1. So we know what the denominator is. Let's simplify it to 2x squared x minus 1. And with regards to the numerator, let's bring all the terms together. So this is the bottom. So let's sort out the top of the fraction. So the top is then therefore going to go to x squared minus x plus 2x squared minus 2x squared plus 2x, making sure not to make a mistake with the negatives. This is therefore going to become x squared plus x, which is equal to x brackets x plus 1. So that's the top. So therefore, our overall fraction is x brackets x plus 1 over 2x squared x minus 1. So the x's are going to cancel out. Well, one of them will. So we get x plus 1 over 2x brackets x minus 1. And therefore, the correct answer option is going to be answer option E. Again, these types of questions are not easy. The main thing you want to make sure is the principle that you're multiplying by whatever is missing from the bottom to get them over a common denominator. And then you just need to be careful about collecting terms, making sure to take care of any negative signs. Okay. Question 21 then. The family tree shows the inheritance of freckles. Which row in the table shows the probability that the next child produced by parents 1 and 2 and the probability that the next child produced by parents 5 and 6 will have freckles? So let's map out the genotypes. So first of all, what we can instantly be able to tell from here is that the allele for freckles is recessive. What we can instantly tell is that the allele for freckles is going to be dominant. Let's call that F. And recessive is no freckles. The reason being, for these two parents to produce children without freckles, they would need to be heterozygous. And the only way they would therefore have freckles is if the allele for freckles is dominant. So this person is FF, this person is F, small f, since not all the children have freckles. And if we draw out the Punnett square, we'll see that FF, half the children have freckles. So now, the probability that the next child produced by parents 1 and 2 will have freckles is going to be half. So it's one of these four answer options. And the probability that the next parents produced by 5 and 6 will have freckles. So let's compute that. Each parent's going to be FF. So F, 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 F. Probability is 3 out of 4, which is equal to 0.75. Therefore, the correct answer option is D in this case. Main thing is figuring out whether the gene for freckles is dominant or recessive. Again, if you have two parents with a condition and both the children don't have the condition, it's going to have to be dominant, because if it was recessive, then all the kids would have the same since the parents are both homozygous. Other thing you want to remember is just the link between genotypes and Punnett squares and how to calculate the probabilities subsequently. Okay. Question 22 then. Hydrated copper 2 sulfate has the following formula. 100 centimeters cubed of a solution contain 10 grams of hydrated copper sulfate. What is the concentration in moles per decimeters cubed? So first of all, number of moles is equal to mass over mR, which is equal to 10 over the mR. So the mR is going to be 32 plus 64, which is going to be 96, plus 4 times 16, which is 64. 96 plus 64 is going to be 160, and each water has a mass of 18. 5 times 18 is 90, so 160 plus 90 is 250, which we can make 1 over 25, okay? And now, in terms of volume and concentration is number of moles divided by volume, which is equal to 1 over 25 divided by 0.1, which is equal to 10 over 25, because if dividing by 0.1 is the same as multiplying by 10, remembering that we need it in moles per decimeters cubed, and this is in centimeters cubed, and 1,000 centimeters cubed is 1 dm cubed. So therefore 10 over 25 is 4 tenths, which is 0.4 moles per dm cubed. So therefore the correct answer option for 22 is B. Okay, so question number 23. A book rests on a table, which in turn rests on the floor. The floor exerts a force P on the table. So let's draw this out. Book, table, table legs, floor. The floor exerts a force P on the table. Force P and one other force constitute a Newton's third law interaction pair of forces. So without even looking at the answer options, Newton's third law states that there is an equal and opposite reaction for every action, i.e. the equal and opposite force to P is going to be the force of the table leg onto the floor, which is going to be equal to P since the table is not moving through the floor. And these will constitute equal and opposite forces that form a Newton's third law pair. So looking through the answer options, the force that the book exerts on the table, no. The force that the book exerts on the earth, no. The force that the earth exerts on the book, nope. Earth on the table, nope. Floor on the earth, no. The force that the table exerts on the floor, yes, because that acts in the equal and opposite direction to the force that the floor exerts on the table. Yep, okay. Again, as I mentioned in my physics video, a lot of BMAT is just knowing your key terms. And if you guys are looking for a BMAT course that really emphasizes key terms, that really emphasizes the principles of science for Section 2, as well as splitting Section 1 down into its core components so you guys can get the highest score possible, make sure you check out sigmamed.co.uk. Me and my friend Hamza have put together an insanely comprehensive and up-to-date BMAT course that we are really proud of. It only costs £30. That is less than the price of a single hours of tutoring. And honestly, it can make all the difference to your BMAT score. If you are sitting the BMAT this year, check out sigmamed.co.uk right now. Alright, so now question 24. The diagram shows a shape made from a quarter of a circle, radius 6, and a right angle triangle with hypotenuse length 9. Which of the following expressions gives the area in square centimeters of the shape? So the first thing is, let's split this into shapes A and shapes B. Let's find the area of B first. So the length x here, we can find by Pythagoras. X squared plus 6 squared is equal to 9 squared. X squared plus 36 is equal to 81. X squared is equal to 45. X squared is equal to 9 times 5. X is equal to root 9 times 5. X is therefore equal to 3 root 5. Okay, so therefore the area of the triangle, which is B, is equal to half times 6 times 3 root 5, which is equal to 9 root 5, because half times 6 is 3. 3 times 3 is 9, so therefore 9 root 5. So that's the first bit. Second bit, the radius is 6 centimeters. Area of a circle is pi r squared. So area of a quarter circle is pi r squared over 4. So it's just going to be pi times 36 over 4, which is just simply equal to 36 over 4 pi, which is 9 pi. So therefore the overall answer is 9 pi plus 9 root 5, which is, in this case, answer option C. The main thing you want to notice is that the answer options have been given in terms of pi and the surd. Therefore, you want to find the answer going off this. Don't approximate pi, don't approximate root 5. Make sure you're good with surds, make sure you know what you're doing, make sure you're making things simple for yourself. Okay, question number 25 then. The picture shows a Siamese cat. This type of cat has a gene which is sensitive to temperature. When this gene is inactive in the cells, the coat color is pale. When the gene is active, it produces an enzyme which causes the coat color to be darker. If this cat had grown up in a warmer environment, its ears, front of the face, paws, and tail would be paler than those shown in the picture below. A student wrote the following statements using this information. 1. The enzyme is denatured at the internal body temperature of the cat, so the coat color is pale. That is wrong. It's not the fact is that the enzyme is denatured. Rather, when the gene is inactive, the coat color is pale. However, it's not necessarily denatured, because the internal body temperature of the cat is going to apply to its face, etc. as well. So the enzyme wouldn't be denatured, otherwise the cat would just be completely pale. 2. The temperature of the ears, front of the face, paw, and tail was cooler than the body temperature, so they are darker. That's true. It may be the case that the enzyme simply works better at cooler temperatures. 3. Coat color of Siamese cats depends on both genes and environment. That's pretty clear given that temperature affects the gene activity. So therefore 2 and 3 are, sorry, not gene activity, enzyme activity. Therefore both statements 2 and 3 are correct, and the correct answer option in this case is answer option G. This is a bit of a biological problem solving question, but it's not too difficult. The main thing you want to understand is it's not the cat's body temperature that's denaturing the enzyme. It is the enzyme is just more active when it's colder. Okay. 26. What is the volume of hydrogen gas when formed when 0.23 grams of pure sodium reacts completely with an excess of water? Assume that the molar volume of gas at room temperature and pressure is 24 decimeters cubed. So sodium plus water is equal to sodium hydroxide plus hydrogen. Let's just balance this. Okay. So 0.23 grams of sodium, number of moles as mass over mR, which is equal to 0.23 over 23, which instead of doing long division, we notice that's 1 out of 100. So therefore, the number of moles of hydrogen that we form is equal to 1 out of 200. And 1 out of 200 is equal to 0.5 over 100, which is therefore equal to, if we have, so essentially we have 0.5 over 100th of a mole of hydrogen being formed. So if 1 mole has a volume of 24 decimeters cubed, what we're saying we need to multiply this by 24, which is equal to 12 over 100, which is therefore equal to 0.12 dm cubed, which is answer option B. Main thing you want to do here is work in fractions and understand the concept. The concept is 1 mole is 24 decimeters cubed. We know how many moles we have, so we just need to multiply to find the amount of volume that this mole that we've created is going to occupy. Okay. 27. A graph of kinetic energy in joules against the square of the speed is plotted for an object of mass 2.5 kilograms traveling along the surface of the Earth. The result is a straight line with the numerical value of the gradient of this line. So, KE v squared. KE is equal to half mv squared. So therefore, half 1 over 2m is equal to ke over v squared. M is equal to half ke over v squared. So what we can say here is the gradient of the straight line is mathematically equivalent to half m from this line over here. And m is 2.5, so therefore half m is 1.25 kg. So the gradient of the line is going to be equal to 1.25, which is answer option C in this case. I hope you guys have enjoyed this tutorial. Ensure you're subscribed so you guys don't miss the next BMAT tutorials I make on the 2018, 19, 20, and 22 papers. 2021 is already up on my channel. Make sure to leave a comment and subscribe. And as well, if you're studying the BMAT this year, make sure you check out sigmamed.co.uk for a BMAT course that does things differently.